Welcome back. This is part 2 of block diagram reduction. We have seen a few rules in part 1. Here we'll see the remaining rules. This is easy, okay. So let us consider shifting of branching point before a block. So this is a block, this is a branching point. So I'm going to shift this branching point from here to here. So the idea behind this is, once I shift the branching point, the signals coming out should be G1, G2x here and G1x. So let us see. To shift the branching point before a block G1, multiply the signal by G1. So here you can see that this branching point has been shifted here. So we multiply it by G1. So it's very easy. So I will repeat again, when you shift the branching point before a block, you multiply the signal by G1. I hope it is clear. So if you are shifting a branching point after a block, I am going to shift the block here. Can you guess what should I do? Like suppose I take the signal from here. The idea is now y2 is what? X into y2 is x into G1. So if I take from here, then also I want it to be x into G1. So let us see. So if I take from here, the signal y1 is G1 G2 into x1. So this signal coming out from the branching point should be, y2 should be equal to what? Should be equal to G1 into x, but it is G1 G2 into x, so we will divide it by G2. So signal should be divided by G2, or in other words it should be multiplied by 1 by G2. It's not divided by, it should be multiplied by 1 by G2. So in both the cases, the signal y2 is what? G1x. So I'll repeat again. Here y1 is G1 G2x, y2 is G1x. If it is after, if I shift the branching point after G2, what will happen? The signal coming out of this will be G1 G2x. So I will multiply by 1 by G2. So y2 will be again equal to G1x. So many problems, when I told you in the beginning, why we learn all these rules, we may have some complicated system. So we want to get the overall transfer function. We want to simplify a complex block diagram. So to simplify a complex block diagram, what we will do is, we may have to shift the branching point, we may have to shift the summing point, we may have to rearrange the summing point. So let us look here. The signal here is x, signal here is y. So the signal here will be what? X plus y, and signal coming out of this will be x plus y minus z. So these two are called summing points. These two are called summing point. Instead of having two summing point, maybe we can have one summing point. So here also, what is the signal coming out? Is x plus y minus z. Or we can rearrange the summing points. We can have x minus z. So here the signal will be x minus z plus y. So we will get x minus z plus y. So all these three set of summing points are equivalent. So depending upon the problem, we can use one of them. So shifting summing point before a block, I want to shift this here. So here it is, output is xg2 plus y. So this, this is x and this is y. So this signal is xg2 plus y. So if I shift it, then also I should get what? I should get xg2 plus y. So when I'm shifting the summing point from here to here, I know that it is going to get multiplied by g1. So what will I do? I divide the incoming signal by g1 or multiply it by 1 by g1. So what will be the signal here? It's not x. I have y by g1, and this is what x. So x plus y by g1 into g2. I will get so in both cases it is x g1 plus y1. So in both cases I'll get the same output. So when you are, so what you should know minimum, if you are shifting the summing point before a block, multiply it by 1 by g1. I'll repeat again, if you are shifting the summing point before a block, you divide it by g1. The idea is you know that the signal is going to be multiplied by g1. So if you are shifting the summing point after the block, so this here x plus y into g, we want, after shifting also we want it to be x plus y into g. So the incoming signal should be multiplied by g. So what is the rule? If you are shifting the summing point after a block, you multiply the signal by g. So that's all. Thank you.